Okay, so I'm gonna try to keep the new stuff to a minimum, but one thing that that I am gonna use is a Jupyter Notebook. Anyone used Jupyter Notebooks before?
I have.
Yeah.
Okay. Okay, so a couple people used Jupyter Notebooks. If you haven't, that's fine. It's pretty simple. It's just so I already have a virtual environment created, and I just install Jupyter. So pip install Jupyter after you create a virtual environment. And Jupyter Notebooks, it will allow you to edit and run your code in a browser. So it runs a server, and it's basically like a hybrid of. So what we usually do with Python, for example, is we open VS Code and create a file, and we write our code in the file, and then we run the file. So that's great, especially for, if you have everything all packaged up and ready to go, then you have a complete program. You can also, if you're just interested in kind of experimenting or like testing a line or two, you can go into the Python shell, and you can just do some quick stuff there. It's ephemeral, but it's quick and easy. And Jupyter Notebooks is a hybrid of those two things. So it basically allows you to you can write code in a little cell. So it's a little chunk, and then you can execute that code, and it allows you to kind of save your progress. So you can, it's almost like creating breakpoints or something. So it's like if you have it's kind of like a live breakpoint thing. So you can execute code and then run a chunk of it. And if you're satisfied, then you can write some more code and then execute a chunk of that. And if you're satisfied, and if you're not, you can go back and change it. So because machine learning in particular, there's a lot of going back and looking at things and making tweaks and, did this work or not? And there are some, long running processes. So it just makes incremental development a lot easier. So I am gonna use that tool. Okay. So once you install Jupyter Notebook from your virtual environment, to run it, so I have this CSV data already here. You'll obviously start with nothing, and you can run Jupyter Notebook, so just Jupyter Notebook, and that's it. And that's going to start the server, and it's going to show you this intro page here. And then you obviously won't have this, but you can create a new notebook. So you'll choose Python 3 as the kernel, create a new one. You can rename it. And then, so this is a brand new thing. And if I look in my code editor now, I see that this exists. So I now have this. And VS Code has a way to kind of helpfully see what a Python notebook looks like. So I can type in normal Python stuff here. So I can do 4x in range. I can execute that. So I just wrote some code here. And then to execute it, the shortcut is Shift Enter, but I can also just press run, and I can rerun it. So I'm running it. There are some other options. I'm not a Jupyter Notebook expert. I don't know all the shortcuts, but that's basically it. You can also do things like, so I'll just do a calculation. So 3 plus 4, and just like in a terminal, it'll automatically like print out the output. So I didn't explicitly print this, but it'll show you. So that's also a convenient feature. So I can do things like x equals 10, and then I can execute this cell. And then in the next cell, I will have this variable available to me. So y equals x. And then I can just do y. So nothing too shocking here. I mean, that's the basics of Jupyter Notebooks. All right, so let's go over here to this gender names thing. So the task we're gonna have is just like that third-party API that we used last week to figure out if someone was male or female based on their name, as our a best guess. We're gonna write that ourselves. So instead of using a third-party service, we're gonna try to implement that ourselves. All right, so a little overview of machine learning or data processing. So in the real world, this whole everything that we're doing, depending on the scale of it, is likely going to get divided up into different subspecialties. But this is kind of just the general. This is like start to finish kind of stuff. So there are multiple ways of breaking down these steps, but in general, I think this is a pretty consistent high-level overview. So one is we're going to frame the problem. We're going to find and explore the data, and then we're going to clean and process the data, and then we're going to extract features, and we'll talk about all of this stuff. And then finally, and this is in some ways the easiest and least important part, we'll actually do the machine learning stuff, which is training and testing a model. So the hard part is the difficult and time consuming part is finding data and then processing it to get it to be usable by a machine learning algorithm. So it's not, unfortunately, it's not entirely magic. So the part of it does seem like magic, but you have to do a lot of work to give it good inputs. Otherwise, you're just going to get, garbage in, garbage out. Okay, so framing a problem. So let's say we need some way to, with reasonable accuracy, determine a person's gender based on their name. So we have an application and we want to add some bit of functionality. So if we were just writing normal code, how might we do that? Any guesses?
I guess without any background, yeah, I guess you could say how the string is made up,
Okay.
combinations of consonants and vowels, and guess that way.
Okay, yeah. So that's good. So we could do something like, well, let's say, so we kind of need some domain specific knowledge, maybe. We could do something like if name. So if the last letter of a name is an A, then something like that. So that's something like this, else. And we could try doing something like this. And then we could add more conditions. So if we could try, if the last letter is A, and then if the length of the name is, let's say, greater than 4, and let's say if, so the point is we could kind of construct our own function here that might actually do reasonably well, but it's kind of complicated and it's not really principled, right? It's not really principled code. There isn't an underlying like structure. It's just kind of, we'll just piece things together and we can always keep adding more things, and it's just a maintenance nightmare basically. So this is the kind of situation where if you find yourself doing this, this may be a problem that's better solved with machine learning. So that's not 100%. There are some pros and cons, but in general, that's the kind of problem where you might want to start thinking about it. Do I want to start just writing 50 if-else clauses here to solve this problem, or do I want to use something else? And you can kind of like push all those if-else clauses onto the machine learning algorithm. You know, it's a black box you don't have to worry about. Okay.
Hey, Chad.
Yeah.
Is it safe to assume we already have a data set? It just may not be representative.
In general, no, it is not. So determining like, okay, I have this problem and now I think, okay, this is a problem I could solve with machine learning. The next step, which we'll get to, is finding data, which is far from, it's far from guaranteed. So there are kind of data sets available. Some of them are free, some of them might not be. If you're Facebook, I can't just like use Facebook's data, right? Obviously they make money by selling that data. So they sell it to other clients that do stuff like we're gonna do. So they're gonna look for patterns, and they're gonna try to predict certain behavior based on certain stimulus and so on. So it's definitely an issue. And actually web scraping can be one way of getting the data that you need. So you might get lucky and there's kind of a ready-made data set, as there is in our case, or you might have to create it yourself, or it might just be prohibitively, it's basically not practical to get, so you might have to just try to think of another way of solving the problem. Does that answer your question?
Yes, thanks.
Okay. All right. All right. So I'm going to click this link. So here's, I've already kind of done some of the looking up here. So we're actually going to use this data set. They actually have a bunch of different data sets here. So gender by name data set. Here's some description. It's text. So there are this many rows, 147,000 rows. So it gives you some references, and here's basically a description of the data. So there's a name, which is a string, gender, and MRF, a count, and a probability. So we can take a look. Oh, okay. So here's one source. We're actually going to use this data. Kaggle, if you're interested in this kind of stuff, Kaggle is a good resource. It's kind of like what is it? One of these like coding challenge algorithm websites, except it's for data science and machine learning and stuff. So there are competitions and so on. But they have a bunch of data sets that are freely available. So if you do a search for like Kaggle data set and then whatever you're looking for, there's a good chance you'll get something. It might not be quite what you need, but so here's another data set which has 95,000, and there's a bunch of names with the gender and then the probability based on whatever. So this probability thing is not going to be useful to us, but okay. So in general, let's assume you have to look for a data set. And so we got lucky and we found one, so we'll continue. If you don't find one that's kind of ready-made, that's going to satisfy your needs, you might have to create it or patch together a couple other data sets or do something like that to get creative. So let's take a look at what we have. So I've renamed this, but so we have name, gender, and then two things that we don't care about. So this is also common. So this data, we can just take a look at it. There's a whole bunch of stuff. It looks like just at an initial glance, it looks reasonable. Nothing seems insane. Doesn't look like there's a bunch of weird stuff going on. So that's something like spot checking your data. You have to do, is this actually usable? So, you know, I read the description, I download the data. Is this actually going to work for me, or is this just total garbage? So it looks like this is good, but we have some stuff that we don't need. So we have what we need, but we have too much. So that's an easy problem to solve. So we can read in our raw data, and I'm just going to use the usual Python CSV library. I'll read it in as a dict reader. You can do whatever you want. And then what I'm going to do is I'm going to have each row represented as a tuple, and I just want the name and the gender. So the other two columns, I'm just going to ignore. Okay. So I'll go ahead and run this one. And I'm going to insert a row below it, and let's see what names. So now I have a list of tuples of, you know, name and then gender. And I can see that there's females and males. So I don't know if this is ordered. I don't know. Do I have like 1% females and 99% males? Do I have null values anywhere? Do I have values that have names without the gender? Do I have some, you know, weird character here instead of M or F? So what is my actual data set? So you'd also want to do some more advanced exploration, probably, just to make sure that the data is what you think it is. We're gonna skip some of that. So now we have the basic data we want, but so this is actually, you know, very good, highly regular data. We don't have to account for nulls or anything like that, but we do. When you do machine learning, you basically want to strip out anything that's extraneous. So in this case, capital letters. So, you know, capital lowercase, this is a distinction without a difference for our purposes. So we're just introducing more noise. So we can strip out the kind of range of our problem set by regularizing our input. So I'm just gonna make everything lowercase. This is a common text processing thing that you'll do. Make everything lowercase. You might also want to check for things like ASCII characters. Do you have like things with accents? Do you have you know, Chinese characters or whatever? If you do, you might want to either try to regularize them, or you might just eliminate those values, or you can do, there are a number of things you can do, but that's something you'd also want to check. The other issue is that machine learning algorithms don't really deal with, basically they only deal with numbers. So everything we give them, we essentially have to convert to a number. So any feature that we have, for example, this M or F, our algorithm doesn't know what an M or an F or anything else is. We just need to give it a number. So because this is a kind of problem where our question is, what is the gender of this name? And the answer is going to be one of two things, right? So that kind of problem is called a categorization problem. And there are a few kinds of like basic types of machine learning problems. There's the kind of problem where I want to predict the price of a stock tomorrow, right? So that kind of problem, it could be anything, right? So there's basically like an infinite range of possible values. So you'll approach that kind of problem slightly differently, and I'm not going to talk about that right now. This particular problem is a categorization problem. So we're going to give it some input, and we're going to say what bucket does this go in. So there isn't an infinite range of things that it could be. It's either A or B. So so in this case, since there are only two possible values, we're basically going to use 0 or 1. So the first thing we're going to do to process this is I'm going to lowercase all of these, and we're actually going to further process these to essentially turn them into ones and zeros. But the first thing we're going to do is lowercase this, and then we're going to turn the M's and F's into zeros and ones. Okay. So cleaning and processing data, yeah, here's some questions to ask. What information do we really need? So we got rid of a couple columns. Can we simplify or regularize our data? Yes, we're going to lowercase it. And can we organize and prepare our data for further processing? So in addition to this, so we want to have kind of three bits of information here. We want to have the actual name, so that's like our input, and we have the gender, which will be basically the output, and then we want to have a set of features, and we're going to have to create these features, which we'll do later. But these features are basically going to be the numerical translation of the name. So we're going to take Barbara, and we're going to turn Barbara into an array of ones and zeros, which sounds very strange. Like, how would you even do that? But we'll see how you do that. So we're going to do another processing step. We're going to lowercase everything. We're going to convert the M and F into 0, and then we're going to kind of set this up. We're going to add this to the tuple so we can run it through a processing pipeline and generate all our features. Okay, so I'm going to have a list, and I'm going to have a list of tuples. I know that. So for now, I'm going to keep the we'll start here. So do something for, let's say, T tuple in, and what is this? Names. So we have our list comprehension set up now. So I know that the third thing I'm going to need, since this is going to be the same for all of them, I can just go ahead and throw that in there. So this is going to be a dictionary called features, and it's just going to be an array, and we're going to populate that later. So that's the first, or sorry, that's the last thing in the tuple that we're going to have. The first two things is the name, but it's going to be the lowercase name. So I have access to the tuple, so I'm going to do T0, so the first element of the tuple, dot lower. So if this were more complicated, you could write another cleaning function or another cleaning pipeline that would do all kinds of other things. lowercase, check for ASCII characters, check for whatever else you want to check for. Okay, but this is a simple version. So we're going to lowercase it, and then we're going to convert this gender into either a 0 or a 1. So T, I'll do 0 if it's male and 1 if it's female. That's an arbitrary choice, doesn't matter. So 0 if T 1 equals M, else 1. Okay, so let's go ahead and take a look at that. Okay, so it looks like that worked. So now my data, so this is all lowercase, so it looks like that worked. The M got turned into a 0, and I have this features, which is ready to go. So Mary is a 1. Okay, so that looks right. So I think we're done with the basic cleaning and processing of our data. So now we're ready to move on to, what is arguably the hardest part, maybe the most fun part of machine learning. Are there any questions so far? All right, why don't we take, let's take like a 2-minute break, and when we come back, yeah, we come back, we'll keep going. By the way, I'll post this code up when we're done, so. Okay, so here we are, we're back to our data pipeline. So we have a problem. We want to be able to guess someone's gender based on their name. We tried to implement it conventionally. It didn't work so well, so we're going to try to use machine learning. So we looked up some stuff online. We tried to find some data sets. We got lucky, and we found some. So we downloaded the CSV and then read it in. We processed the information. We dropped stuff that we didn't need, and then we cleaned it and regularized it. And we're now prepared to start extracting features. Okay, so to create the features, so what is a feature? A feature is something like we did up here, where we do, initially we did like if name, if the last letter of the name is an A, then do something. So this would be a feature, right? So if I have the name Bob, and I can say, the last letter is A. Is it true or false? So that's a feature that we could come up with. And the feature we have to come up, the features we come up with are going to be relevant to the problem. So it's not always, sometimes it's easy to find features, sometimes it's really difficult. Sometimes things that you think will be good features are not. So in general, a good feature is something that will help your algorithm solve the problem. So if we know, and how might you know that? Well, one way you might know that is by querying your data. So we're not going to use pandas or anything like that, but you might want to do some queries and say, so how many, what is the ratio of male to female names that end in A? And you might do that query, and if it's like something that's more than 50-50, that might be a good feature. So if it's like, 70% of names that end in A are female and 30% are males, then that's a really good feature. So that's something that your algorithm can grab onto and say, okay, if I have an A at the very end, there's a, more than likely it's going to be a female name. Then you can use that in conjunction with other features and try to kind of figure out what the correct answer is. So for these features, the way we're going to structure it, so I have this one function written at the end. We're going to need this at the end, so you can just ignore it. But we want this feature to be an array of ones and zeros. And those ones and zeros are going to represent features, basically true or false. So does Jennifer have X? If it's true, it'll be a 1, or false 0. It doesn't really matter, but either a 1 or a 0. So ultimately, we're going to transform Jennifer into a list of ones and zeros. So how do we do that? Well, let's think of some features. So one feature we could use is we'll actually start with the last name is an A thing. So def last is A. And yeah, so the way we want to structure this is we want to set up a pipeline. So I want to take in a given tuple that I have here and run it through a whole bunch of these functions that we're going to write. They're going to extract features, and I want it to give me the same. I want it to have the same input and the same output, so I can just chain them together, and it doesn't matter. I don't have to worry about. I don't have to worry about anything. So we've seen this before with functional programming, but this isn't in the application of that. So it's going to take a tuple and it's going to return a tuple. So we'll just say here, it's going to take a tuple, and then what we want to do is I want to check if the first element of the tuple, which is our name, and then the last character of that, if that is an A, I'm going to return the, let's see. Actually, I'm gonna modify this place. So T2. So sorry, this is not the most readable stuff. I apologize. I don't like using these indexes, but that's how it is. So this dictionary features, I could do something like yeah, maybe I'll just append. Let's do. Actually, I'm going to do it slightly different way, so I don't have to repeat myself here. So yeah. Anyway, that's fine. We'll do it this way. So append A, else I'll append. Oh, actually, sorry, I'm not going to append A. So this is going to have to be 1 or 0. So I will append a 1 here if the feature exists, and a 0 if the feature doesn't exist. And then I'm going to return the tuple. So we're going to start with just 1 here. So the last character is an A. It's going to take in a tuple. It's going to check if it's an A. If it is, then we're going to append a 1. So we're going to end up with features an array of 1, and that, to us as humans, we know that's an A. The algorithm doesn't really necessarily care what it is, but that's it. So we've thought about what is an informative feature that just might help solve the problem, that might distinguish something from belonging to one category versus another, and we pull it out and then turn it into a number. Okay, so we'll keep going from here, and we can come back and add some more of these feature extractions. But for now, we'll just have this one feature. Okay, we got that, and I'll run this cell as well. So now I have access to all this stuff. And then here, this is some more boilerplate. This is basically just going to run all of our clean data, clean names. So I'm going to clean. It's going to run all of our clean names through this pipeline. And this pipeline is going to have all of the feature extractor functions that we've written so far. We just have these two. Okay. Are there any questions? So, you know, I'm maybe going a little fast here. This is just boilerplate to facilitate. So you don't have to do this. You could kind of just do it, you know, ad hoc individually. But once you start doing more stuff, it's easier if you have some basic infrastructure in place. So it's easy to add and make changes. It's very easy to get lost with this stuff. Okay, so I've got this pipeline. Let's see if that worked. Let's take a look just as a sanity check. Okay, so it looks like nothing blew up. So we still have our name, we still have the category, and now we have something in this features. Let's see if we have an example of someone whose name ends with an A. So here's Patricia. So she gets a 1 here. Okay, so it looks like that worked. So we'll keep going with that. So once we have our features decided on, and we can, like in the real world, you'll be constantly going back and making changes and adding things. And oh, I thought this was a good idea. It's actually not. I'm going to get rid of it. I'm going to change blah, blah, blah. So we just have a very simple thing right now. We can go back and change that. So we have our features. So now what we want to do is train and test our model. So we have all of this data with all of this feature, with all these features, and it's ready to go. But if we, so the problem now is we have to choose a model to use, and then we have to run our data through the model, and we have to somehow decide if our model is good or not, or the extent to which one might be better than another. So you need to control for a couple things. So one problem is that if I just take a model and I give it all of the data that I have, just 100% of the data, throw it in there, let it run, there's a danger that my model might turn out to be very accurate, right? So I might get like, oh, it's 95% accurate. That's so awesome. And then you use it in the real world and it's complete garbage, or it's just, maybe it's not total garbage, but it's just not nearly as accurate as you thought. And the problem with one major problem with machine learning is something called overfitting. So if I have this data set, the model that I train might just learn this particular data set really well. But if I give it any new data that's, you know, similar, but not quite exactly right, it doesn't know what to do with it. So you want to make sure you avoid overfitting. So if you train a model and you see that the accuracy rate is like 99% or 100%, you should be very skeptical unless you're dealing with very, very simple data. Okay, any questions about that so far? Okay, let's continue. So in order to avoid that problem, we're going to split the data that we have, and we're going to have a training set and a testing set. And there are different ratios you can use, but I'm just going to more or less pick an arbitrary number. So first thing we probably want to do is, well, how much data do we have? Let's see. Okay, we have 147,000 rows. So a typical kind of train test split would be, 80-20 or 70-30 or something like that. So you might think, well, let's just give it all of the data so it can be, really well trained on all of the data, but it doesn't actually work that way, unfortunately. So there are built-in functions that can do this for you. They can, like shuffle all the data and, randomly select a certain percentage of blah, blah, blah. We're not going to do that, but we're going to kind of do everything from scratch just so you can see how it works. Most of it is not that mysterious. So we're going to import NumPy, and this is something that that we're just going to have to. This is just something you have to do so that the function won't yell at you. So this is just some boilerplate here, this NP array. So don't worry about that for now. So we're going to create the training and test splits. So clean with features. So I'm going to import shuffle. This is, not like the most scientific way to do this, but it'll work. So import random. And what I'm going to do is I'm going to shuffle this data. So I think this is how you do it. And this, let's see, comment this out for now. Let me just check this out and make sure that it didn't blow anything up. Okay, so it looks like it did in fact shuffle it, so that's good. Another thing that you want to watch out for that we're not really accounting for is, since we have two categories, we want to make sure that our input data is, roughly evenly distributed. So ideally, 50% females, 50% males. This data set is actually not like that. It's a little skewed, so there are more females, but that's fine. We're just going to ignore that. It's not like a hugely disproportionate thing, but that's something that you should be aware of as well. Okay, so we've shuffled our data, and now what I'm going to do is I'm going to select, so train, let's see. Yeah, so I'm going to do train set. And that is going to be, so I'll take like roughly 80%. So I don't know what that is, but with features, and I'll take the first, I'll just do 100,000. Things simple, 100,000, and then test set. Let's do 100,000 to 120. So I'm not going to use all of the data. That's fine. Okay, so now I have my training set. So I got all of the possible data that I have, and I've, for whatever reason, I'm not going to use all of it. There's also a third thing you might want to do, which is have like an out of training sample. So have like a totally different set of names, and then once you've actually trained everything, you can do like a sanity check. But yeah, not gonna worry about that right now. So we have our train test, our train set and our test set. So now what I'm gonna do is we need to further divide this. We need to further divide this training and test set into the features and then the categories. So we're going to end up giving our model basically a bunch of names and then a bunch of categories. So like the correct labels. So this I'll call this labels actually. So this features is going to be, you know, like Samantha, except turned into ones and zeros. So we're going to extract everything here, and we're going to do from the train set. Okay, and then we'll do the same thing for the test set. Okay, so I don't have NumPy installed, so I'm going to do pip install. Let me save this first. Then I'm going to quit the server. So Control C. Yes, I would like to quit. And then I'm going to do pip install NumPy. So NumPy is a common library that you'll use with machine learning and any kind of data processing. Okay. So got NumPy installed. So I'm going to rerun the Jupyter Notebook. We'll go into here. All right. So we'll go down here. I'll run this stuff again. So run that. Run that. Run that. Still good. Okay, so I'm going to come here and try to run this, and I don't get the error anymore. So let's go ahead and take a look at, actually not clean those features, but we'll just do train set features. So in this case, here's our, does it end in an A? No, no, yes, no, yes. And then the labels is going to be all of the, is it male or female? So it looks the same, it's confusing. Typically with features, we'd have more than one thing, but so here's, you know, I think one's female. So female, 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 male, and so on. So it's, again, difficult to keep track of because now we have these, you know, parallel lists and we just need them to match, but we're not really creating like a cohesive data structure that actually connects them. So unfortunately, that's kind of how it is, but it's not, you know, it's not ideal from a programming perspective. Okay, so I'm gonna, let's see, toggle the outputs again. I don't know all the shortcuts, sorry. Okay, so at this point, we've gone through, let's just review again. We figured out what our problem is, which is guessing name by gender. We went and looked for some data sets on the internet. We found some, so we're gonna process them. We pull them in, drop stuff we don't need, regularized it, clean, process it. So then we get a bunch of prepared, kind of prepared stuff. And then we extract the features. So this could be as long a pipeline as you like with as many features as you like, and you can play around with it and then test models and see if, you know, does adding this feature make it better or worse, things like that. And then, okay, so we actually did just boilerplate for the pipeline. Then you have to do the train test split. to ensure that you're not overfitting your model. And then we're basically here, what we're doing is we're taking our train test split, and we're further dividing it into the like our inputs and then the outputs. So the features, which is the name, and the labels, which is the gender. So now that we have all that stuff, we can actually basically the easy part is training the model. So we can go to the I'm going to use Scikit-Learn. So Scikit-Learn is great. It's a Python library. There are several machine learning libraries. I think this is probably the most user-friendly. But feel free to argue. But the documentation is good. So if you go here to the main page, you can see clustering. So there are different kinds of machine learning tasks or problems. So classification, that's what we're doing. There's regression, which is like predicting a stock price. Clustering, which would be like what's the thing I'm thinking of? Sorry. Like topic generation. So if you have a bunch of text and you can cluster the text into groups, like based on like topics or supposed topics. We don't have to worry about any of that stuff, but so that there are a few kinds of machine learning problems. There are classification is a very common one. So we know we want to do classification, so we can come check out the documentation here. And there's a whole bunch of algorithms that are available to us to try to solve this problem. And you might ask, well, what's the best one, or which one should we use? And I think the answer is, even from experts, is try a bunch of them and then see what works the best. So there's kind of the process. This process involves one, choosing, let's say, the best model, the best algorithm to use. And there's also what's called hyperparameter tuning, which is, so almost all of these models will accept other parameters that affect how they run, and you'll probably want to play around with that as well. And there are actually functions built in that will kind of automate that will run your model with a range of possible hyperparameters, and then you can choose the best one. So I am not a math expert. I'm the opposite of a math expert. So don't let all of this intimidate you. And if you are a math expert, then good for you. And you can probably use this stuff a little bit, more intelligently. But we're going to choose a couple of these. So nearest neighbors. Nearest neighbors is one. Let me look. There's a simpler one. The decision trees. Yeah. So decision trees is conceptually, I think, probably the simplest to explain. It's basically just going to create a bunch of if-else statements. So you can look at, let me see. Yeah. So here's an example of a decision tree. So the documentation, almost all of these algorithms will follow similar structure. So we're going to import this tree algorithm, and unfortunately, you'll encounter this if you start looking into this stuff on your own. X's and Y's, basically, for the thing you're looking for, and then the category. So X's and Y's, I don't really like that. I find it kind of obnoxious. But so here is, these are like the features. So this would be, a thing. So this would be like a name with two features, and here's another name with two features, and then here's the correct categorization or whatever. So that's how these little examples work. So you have your data, you fit the model, and then you can add new predictions and test them. But anyway, so the tree model is basically, it's going to create like a bunch of ifs, pretty literally. So something like this. Let's see if I can zoom in on. Yeah, you can't really read this, but so this is a decision tree model, which is basically just a bunch of ifs. So if this feature is like this and something else is like that and something else is like this, go here, otherwise go here. And if this is like this, so it's fairly straightforward. Most of the other models are not that transparent. So decision trees, that's a good one. Naive Bayes. So we'll use this one. It's often used for text kind of analysis. But they all, even if you don't understand any of them, which I basically don't, you can still try out a bunch and see if any of them look good. So I've just picked out 3 of them here. And because we have a small data set and everything, we can run this and it's not going to take 10 hours to run. So that's nice. That's something you have to watch out for as well. So let's see. I'm gonna have to change the inputs here. So train set features. That is the same, train set labels. So here we're doing is just importing the model that we want, in this case, Gaussian NB, which is one of these that's available. And then you create an instance of the class as we're familiar with, and then you call the fit method on it and you pass it basically all of the names and then all of their correct categorizations. So that's basically that. Let me see. No model, Scikitlearn. Okay, yeah, sorry, I have to import this as well. So I'm gonna go back. I'll save this real quick. Stop the server. And then I'm gonna do pip install SCI. No, I think it's Scikitlearn, yeah. There might be a couple aliases here. So Scikitlearn. All right, so that's installed. I'm gonna run the notebook again. And I'll go back. And I'm just gonna run everything. So there's a restart and run all option. So I'm just gonna do that. So it's gonna run everything. So here we are. You can see the asterisk, that means it's running. So it's sometimes it can take a minute to run this stuff. We'll see. Usually these don't take that long. Okay. Okay. So at this point, we've gone through everything, and now we have these trained models. We have 3 trained models to choose from. So the next part is we're gonna take a look at all of them and see how they perform. So we have our training, we train these models with our training data. Now we're gonna test them with our test data, which makes sense. So train, let's see, test set features, test set labels. Okay, so we take the model, for example, this Gaussian model right here, which we have trained. So we now have a trained model, and then we're gonna call the score method, and we're gonna pass it again, like known stuff. So we have a bunch of names and then a bunch of the correct labels, and we'll see what percentage it gets right. So this is all not very impressive. They all actually perform pretty similarly, which is surprising. And if we ran all this again, we would likely get slightly different percentages here, but they should be roughly in the ballpark. So we only have one feature. So what that tells us is that this one feature is helpful, but you know, we definitely want more. So 60% accuracy when 50% accuracy is the guessing baseline is not great, but it's better than nothing. We just have a single feature. So let's add some more features and see if we can up this a little bit. I'm gonna copy so this doesn't take forever. Fine. So I'll actually just leave that there. That'll kind of, yeah, that's fine. So I'll add another feature extractor to the pipeline. So this is basically like a more robust version of this, where I'm basically looking at all of the vowels in the last letter, and I'm turning it into an array. So an A would look like this. So 0, or 1, 0, 0, 0, 0. An E would be 0, 1, 0, 0, 0, 0. And if it ends in a consonant, then it's just going to be all zeros. So again, this is often called one-hot encoding. So we have an array of zeros, and then so if you have the alphabet is often represented this way. So it would be like an array of 26 zeros, and then A would be 1, 0, 0, 0, blah, 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 and X would be 0, 0, 0, 0, 1. So that's how this kind of thing's done. So here's another last letter. I'll throw in, let's see, we could try doing length. So length is probably not going to be an informative feature, but that's something that, just trial and error. Just if, try it out, see if it works. If it doesn't work, then try something else. And then I'll use this as well. Throw this one in there. So this is basically the entire alphabet. So every name will basically get a 26 character array, and then all of the letters that are in there are basically going to populate with ones. So it doesn't account for if you have 2 of the same letter, but there you go. Okay, so these are just some examples. So let's see what it looks like here. I'll run this pipeline again. Let's see. Let me restart this. So I often have this issue where it seems like stale data just doesn't update. So I'm just going to rerun all this and see what it looks like. I'm getting an error somewhere. Oh, I know what happened. So I didn't add these functions to the pipeline. I'm gonna have to add all these. So we've got last letter. And then what do we got? Name length. So again, the features, these are features that you will come up with either just domain knowledge or guessing or kind of playing around with the data you have to see if there are any patterns. Okay, so that ran. Now we can go ahead and take a look at these. Let's see what this tree. Okay. So the display here, but you can basically see, let's see, maybe there's 7 there. Well, so let me do cleaned with features. Let's look at the 0 and then clean feature 0 and then the second element. So here are the features. So we basically have one giant list of, I think I changed something here, but that's fine. So I'm not using all 1s and 0s. This is the number. It's probably coming from the val, but that should be fine. Okay, so my name is now represented by this list of 0s and 1s and apparently some other digit. Okay, so now we have more features. So let's go ahead and train the model and let's see if we get better than 60%. So that helps. So now our best one is at 75%. And the worst one, yeah, is at like just under 70. So you could try a bunch of different models and then try playing around with the parameters and then just reiterate. So is 75 good enough for your application? Maybe, maybe not. You could definitely, I mean, we could definitely improve this, but we're not going to spend all day on it. So let's test out a model real quick. So ridge classifier, we'll use this one since this performed the best. So pickle. So once you create a model, oftentimes depending on what you're doing, it could take a while to train it. So you don't want every time you run the application to have to like retrain the model. You're just repeating the same work over and over again. So it's a good idea to save the model. And because the model is, and it's an object, you can't just save it in a file, and not directly anyway. So we have this pickle module, which is a part of the standard library. And it basically allows you to save objects. It's a binary file format. So it allows you to save objects. So you can save any, like you could save a dictionary or a list or whatever and save it as a file and then like open it and access it later. So we're going to do that. We're going to save it as write bytes. So that's the WB there. And then we're just going to do pickle.dump. So we're going to take the object that we want and save it into this file right here. And then looking at VS Code, I have this chosen model.pickle. I can't really get anything useful out of it by looking at it because it's binary, but we can open it. So this OOS names, I'm gonna copy this. So here are some out of sample names, which are, kind of made up. Let's do. So just a few names which are made up. So this is like a kind of a sanity check. So our model's accuracy is 75% or something like that. So if we test it on some out of sample data and it's like way off, then maybe there's a problem with our model. Maybe our model is overfitting, or maybe the data that we're trying to give it is not really representative. These are made up names, so, but in any event, it's a good sanity check to do. So let's see, I think this should work as is. Let's see. I'm reading in the file, that was fine. The names. So I'm basically just like redoing the pipeline. Ideally, I would have these set up as functions so I can reuse them, but this is just an experiment. So reduce features and categories. So I'm going to read back in the pickle file. Chosen model should be right here. Score, names, features, names, categories. Oh, the pipeline. It's strange. And try rerun this again. Any questions in the meantime? Okay, yeah, so again, the problem with the notebooks is that like stuff gets stale. It can be an aggravating source of errors. I think Jupyter Notebooks is a good way to develop, but once you have something, I definitely prefer putting it in actual code so you can run it cleanly. Okay. So we have our chosen model, which tells us that the accuracy rate is 75%, which is okay. I mean, depending on the problem, like 75% might be really good, might be really bad. So you just have to, it depends on the specific domain that you're working in. But here, it looks like the sanity check is comparable to the train test result. So we trained it, we tested it on data that it hadn't seen, but that was part of our original sample. And then we're kind of doing a small sanity check on data that wasn't even part of the sample. And it looks like it's comparable, so probably checks out. And so all of these zeros right here, again, we have names, but we have to convert all of those names into features. And then when we predict it, we get this, and then the answer we get back, the answer. So these are all categories. So 0 is like male, 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 male. So if we look at our test data, it should be 5 males and 5 females. 5 males, 5 females. We can look here. So 1, 2, 3, 4, 5. So it did well. It guessed all of the males correctly. And it guessed the first and third females incorrectly. So Tegan. And if you look at the female names, especially the ones that it guessed incorrectly, you can see that they both ended consonants. So, there may be that may tell you something about how the model is working, and maybe if there's some tweaks you want to make, maybe it's overly reliant on vowel endings or something like that, and you could use that information to go back and reiterate again. Okay, so how's everyone doing?
It's a lot.
Yeah.
A lot's a good word for it.
So it's a lot. You're not meant, it's just meant to be, this is an initial pass, and this is like, basically the whole thing.
So with your job as a data engineer, are you kind of like wrangling and cleaning all that data and then giving it to like a data scientist and they're like dealing with all the models, or are you?
Yeah, so it's depending on where you work, the roles may be a little different. So it's basically writing code. So we have, a whole bunch of different pipelines. So we pull in data from lots of different tables. which is part of what we do, as data engineers, pulling in data, making sure that the data is updated, and then we have code, which is basically like the pipeline. So it takes this raw data, goes through, a whole bunch of processing, including like, not just removing stuff, but like joining tables. So, we want to get some data and it exists on several different tables. So we have to join the tables together correctly and then do other kinds of filtering and blah, blah, blah. But so in the real world, it's way, way more complicated than this, depending on what you're working with. But that's the basic idea.
Okay, cool, thanks.
All right, I'll stop this now.